Okay, guys, let's settle down and let's get started with this presentation, please. Could we get the doors? Yep, thank you. Welcome to this session about customizations, about extensions, and so on. My name is Peter Velits, and I have here with me Robert Badawi, who is a fellow program manager for Microsoft, but we're not really here to add that much value. The value comes from this gentleman over here, Joel Leichty from SA Global, who is going to share with you his experiences and the do's and don'ts and experience that he has from numerous upgrade stories for his company, SA Global. Now, in order to set a context of what he's going to talk about, we thought we would just run through the concepts a little bit so that we have them present when he starts talking about models and packages and stuff like this. So we want to describe models and packages. So models is just a group of elements, as it says there. This is metadata, which can contain source files as well. And that typically is a rounded thing in itself that constitutes something that you would want to distribute. So there's an example here with a warehouse management model. And all these models, you can create numerous of those, and you can put them into packages that can contain any number of these models. And packages are the concept that you do deployment of, and it's the compilation unit that contains one or more models. So again, it contains metadata about describing the models. It contains binary files, reports, and all that stuff. So let's take another overview here. So in this case, we are showing how these are built up in a one-to-n relationship between packages, which maps very closely to assemblies. So a package maps to an assembly. It can contain contributions from different models, 2 models in this case. Each of the models, in turn, can be made up of a multitude of projects in AX. So a lot of projects can contribute to one model. A lot of models can contribute to one package. There is the concept of dependencies between packages. So packages can depend on one another, which is probably pretty obvious. So if you look at this in your preferred way of looking at metadata and the application, which is the Application Explorer, you will be able to go into something we call model view. And in the model view, you will see all the models listed here. In the dark gray thing here, you will see the package, as it says. So we will probably at some point show you how this all works in Visual Studio. Robert will be here to take us through that if you have any questions on how that works. As we talked about dependencies, there is a great tool in AX today in the development environment in Visual Studio to actually show you these. So there's a view package dependencies operation, and it'll create a DGML representation of the dependencies between packages. So the application suite package here contains 3 different models in there. And as you can see, the dependencies are between the outer boxes, not the individual models. All right? So go in there and investigate your models and look at the dependencies between them. We've made this much more public, much more visible to the users of our product now in Visual Studio. It's much easier to understand these concepts because they map directly onto what you're working with in Visual Studio. So we've made that a little more easy to understand. Now, the topic of this session is customizations and the concepts that are involved in that. And I think I'll maybe leave you to go through that, Robert.
Sure. Thanks, Peter. So how many in this room know AX 2012 or AX7 already? Great. So this actually slide makes some sense. So as you know, we do have a concept of customization coming from the good old days of AX 2012, which is overlaying. And if we want to put it in the AX7 or the new Dynamics AX world, it's basically what you're looking here on the left side of the screen. You have a lot of models. They all... Thanks, Peter. So all of these models eventually compile into the same assembly, and this is what we would call a package. So if you are purely overlaying in the AX7 world, you are basically placing all of your models in one package, and they're all compiling into the same assembly. This is what you see on the left side. Where we want to get to, and this is the preferred method, is an extension-based customization system where every model is in its own package. So nobody's compiling into anybody else's assemblies. You can really think of one package, one assembly to make things simpler. So we have Microsoft shipping the application suite, some ISVs extending the application suite in their own package. They compile into their own assembly, and a partner takes those two ISV solutions, puts them together, and creates a third package that actually extends both. The hybrid version of this, which is the one on the right, is how most solutions are being shipped today. Everybody is using extensions as much as they can, but there are still scenarios where you need to overlay. We're pushing more and more towards an extension-based mechanism, but not everything is ready yet, either from the ISV code base or from the Microsoft code base, to only use extensions. So most of the solutions deployed today will look more like 3. With one exception, and Peter's going to talk about this in Friday's session, is the platform itself. There are models in the Microsoft, there are models that Microsoft ships. We refer to them as platform models. These will actually be locked, so you will not even be able to overlay them. But it's not the topic today. We'll talk about that on Friday. So yeah, I hope this gives you a good representation of the difference between overlaying and extensions in AX7. Next slide. So basically, this is another representation of the same concept. It shows you how you're starting with metadata in AX, tables, forms, and classes. And there are 2 types of extensions. You can extend metadata or extend code. Extending metadata, you'll be adding fields to tables, or you will be adding controls to forms. You'll be adding new tabs to forms. You'll be reordering things. We even support changing some properties and so on. And there's the concept of extension of code. Extension of code come in the form of event handlers, plugins, which is a new concept in AX7 too, and things like extension classes, extension methods, and so on. So every update to the platform we have, we're adding new and new concepts. We're getting to the point where it's quite a rich set of features in AX7 that allow you to customize without overlaying.
Sorry, Beyonce, eat your heart out here. So let me just go over the extension value proposition just one time. So the whole idea about this is that you will have compile isolation, and performance of the compiler will be much improved. So what you're doing when you're building extensions is that you're building your own little assembly, like we probably understood from the last slide, and the artifacts that you have there will be far fewer, maybe far less complicated than the actual model that you're extending. So the compilation and handling of all that is going to be far, far easier than managing the whole overlayered model. We've also built a strong story in LCS and application about how to do the deployment of this, how to service it. There's a whole application lifecycle management story that goes with this, that supports this story, and it works really well. But the real crux of the matter, for me at least, is the fact that you are not incurring the huge upgrade costs that you were before. How many of you were in Tarek's session a few hours ago? A few of you were. You noticed that he was very insistent on the value of extensions. And the idea here is that you will be able to make, instead of in the overlaying scenario where you make a fix which is very, very intrusive, and then you have to think about that fix every time the source code changes because a hot fix comes in or because something happens, you have to think about it and you have to maybe redo it again. When you have that, one nested if statement within a while statement within this, and you do something there which is very intrusive, you don't have that anymore because it all becomes your code and it does exactly your stuff. So you don't depend on this anymore. You're decoupling yourself from the source of code that's coming in. So again, the original artifact that you are modifying, or is not modified rather, you are just reacting to changes that are happening there. And how this works, it may seem like magic, but of course nothing is really magic. The way that it works is through some clever combination of metadata that describes the original artifact and the updated artifact. So we have a way that those are merged into the effective resulting artifact. we have some, oops, we have some interesting things that we do with code generation, so that we can handle extension methods, and we have a new set of features that allow you to augment methods, so that you can add state as well to existing classes, and instance methods and static methods. I'll talk a little bit more about that Friday, but that's the way that it really works. So if you say you did an extension where you added a field to a table, it's combined in the sense that at the end of the day, you will actually have that extra field on the table in SQL, of course. There'll be a DB sync that takes care of that. So things are combined seamlessly. You don't have to think about it. That's the real crux of the matter. So we did a little list here of what you can actually do today. I hope we didn't forget any. But the reality is that we have a very, very broad palette of things that you can do in extensions. One thing you can obviously do is to create new elements. That goes without saying. But you can extend tables by adding fields. You can add fields to field groups, create field groups. You can do the same with forms, where you can add controls. You can even now add form parts to forms. That's something new that we added for update 3, which is coming soon. Menus, of course, there's a concept of extensible enums, which makes it easy for you to not have value clashes when different vendors add enums. There's data entities, there's queries, there's views. Those are new additions as well. You can add field mappings to table maps. That's the metadata part. On the code side, you can obviously create new X++ classes. But one of the really cool things is that you now have application events. So remember, in the old days, you had to override a lot of methods, do insert, whatever they were called. That is history now. You don't need to do that anymore. Today, you just react to events that are triggered down beneath the kernel, and you'll just react to those. We have a lot of these framework events. You can add your own events. You can do pre and post as well, as you've always been able to do. We have a concept of plugins, which is sort of a higher level concept where you can package a behavior, a set of behavior, into one plugin, and you can switch between the plugin that's applicable to you in your particular scenario. So for instance, tax handling would be one thing that you could put in a plugin, and you could do tax for India in one, tax for the US in another, and so on. There is this concept of extension methods that I'll go through on Friday, and as I told you, we've extended that quite a bit. I seem to use extend a lot here. Anyway, but that's all theory, that's all good, but let's hear from the guy who knows what he's talking about now. Let's hear the partner view. And what's really the point of all this? How does it work in real life? So Joel, take it away.
Thank you. So my name is Joel Lichty. Thank you for having me. I'm from SA Global. And I'm the Director of Product Management at SA Global. We run AX internally. We're a partner who implements AX, and we also have kind of a partner-led solution, and we help ISVs with their upgrades and code management. So we have lots of different hats that we wear in terms of AX7, and therefore have quite a bit of experience. And one of the things I've found from that experience is, from a technical details perspective, a lot of people, new developers, can understand the extension story. They can understand the technical components, but it's maybe a little bit hard to see the future in terms of why do I want to do all this and what is the benefit? Because sometimes going down this extension path, there are some trade-offs involved. And so that's kind of what I want to talk to you about today, is why it's important. So I want to talk about it in some different areas. First of all, upgrades. So what does this extension, how does it impact upgrades? And also trying to paint a vision for how upgrades will look in AX7 and how they're different than upgrades looked in AX 2012. The next one is dividing up packages. So obviously we have this package concept in AX7, so I want to talk about some reasons why you might divide up your code base if you're an ISV into some separate packages. How this technology impacts design. So some of the things you might have to go through from a design perspective and some of the trade-offs you might have to make when you're designing a solution. And then finally, just some practical tips and experience when you're upgrading from 2012. When I do get to the end of each of these sections, I welcome questions. So please raise your hand if you are curious about anything during this process and during this presentation. So upgrades. So first, let's think about the difference between the code base in AX 2012 and AX7. So in AX 2012, we kind of had this monolithic code base. Everything was compiled together. Pretty much everything was overlayering, and it was all one big thing. We can see how the world is changing, and I have kind of a very much simplified version of packages in AX7. This list could be a lot longer. But if you think about it, there's kind of 4 major groupings of packages. Of course, as a customer, I have my own customizations. As an ISV, I bring those to the table. And then Microsoft has their packages. And you can see from a model perspective, as a customer or an ISV, generally I start overlayering in the application suite. And the application platform, as Peter mentioned, I can't overlayer, so those are just extendable only. So that's kind of the difference between how the code is organized. So how does this impact upgrades? So in AX 2012, because of the dependencies between these different models, it generally meant that I had to upgrade the entire application at one time. And that meant I had to test the entire application at one time. It was hard to take things in chunks. And because of that, upgrades were expensive and infrequent. I could, a lot of times, depending on the customer, some customers just, whatever version they were on, they just stayed on it because if it's working, why not? And but if they do upgrade, sometimes it was less frequent that they would do so. And also, when you're not dealing with a cloud technology, when you're dealing with on-premise, upgrades are more optional. So how is it different in AX7? Well, in AX7, we're starting to get some independence with these upgrades, where I don't necessarily have to upgrade the entire application at one time. Customers are probably going to have to do maintenance ongoing. We're going to get less in this world of that I just get stuck on a version. When you think of a cloud world, a lot of times some of the upgrades are more forced, and I can't just stay on a specific version that I'm on. I think we'll start to see that, as Peter mentioned, like the platform and foundation are locked down. Well, why are they locked down? They're locked down so that they can be serviced ongoing and not have these dependencies where there's overlayering in those models, and therefore I can't service them. So that's why they're locked down. And I think we'll start to see in the future where you just kind of schedule an outage and say, yes, I'm ready to take up the new platform and the new foundation. But in a cloud world, that's probably required. I mean, there's probably times that the Azure technology continues to move on, and so Microsoft really needs the product to be upgraded, at least from a compatibility perspective. Also, browser technology, as we know, changes all the time, so that's another compatibility issue that you could run into. So when we think about upgrading, I think it's kind of helpful to think about it in terms of starting at the bottom of your application in terms of packages and moving up through the stack. So I kind of think about it in upgrading from the bottom up in reverse order of dependency. So for example, the platform and foundation would generally get upgraded first, and then I would move through the application suite, and then I might move through the ISV package. The customer modifications there's not a concept of upgrading because I'm just refactoring them as I go. But this gives us an opportunity to take the upgrade in smaller chunks, because sometimes the bottleneck for an upgrade isn't necessarily the technical components of doing the upgrade. Sometimes it's the functional effort involved in regression testing the entire application if I'm upgrading the entire thing at one time. So I think from a vision perspective, if we can take these in a little bit smaller chunks, we have a better chance of being successful. In addition, there's times that if I have an ISV package and I'm just happy with it, maybe I don't want to touch it. Maybe it involves making payments or something, and I'd rather kind of keep that code as stable as possible, but I want to take all the new additions that Microsoft has brought out and upgrade the application suite. So that is the kind of the purpose of splitting up the application, is so that from a servicing story, we have this opportunity. Of course, there's always exceptions to every rule, and of course there's times that I'm going to want to upgrade an ISV solution, because they came out with a hot fix or new feature that I want to uptake. And I guess the bottom line there is it's a bit of a mixed bag in terms of whenever you're dealing with dependencies below a package, whether it's overlayering or extensions, there can always be dependencies in a lower package that don't exist. So for example, Microsoft might come out with a new data entity that an ISV extends. Well, from an upgrade perspective, when I try to install the new ISV package, if I don't have the application suite there, it's not going to work. That extension won't work because it says I can't find the thing I'm extending. So that's why it's going to be a little bit of a mixed bag when you're not upgrading from the bottom up in terms of will everything just compile and will everything work. And that's that's true even if you have 100% extensions from your ISV solution, we're still going to have to deal with those issues. So I think it's important from an upgrade perspective to just kind of keep this in mind about the servicing story. And I think the last thing on upgrades is, the bottom line is the more we can keep in extensions and have those extensions in a separate package, the simpler the story will be. Because anytime you put overlayer elements in the application suite, you're impacting the upgrade of the application suite. And that's a key point to take away. So if you put code, even if it's extension code, anytime you put code in a package that somebody else owns, you're impacting the upgrade of the ability to upgrade that package. So you just want to keep that in mind as a developer, to be careful about when that's happening and to be very conscious about it. The next thing I want to talk about is some strategies for dividing up the packages. So a lot of times we talk about this as just having one, but there are some reasons where, especially in ISV scenarios, where you may want to have more than one package. For customer modifications, generally all the code is sitting in one package. So that's pretty straightforward. Again, it's a general rule. If you have a larger customer with a lot of code, there may be some reasons to split it up, but that's a general rule. You just have one. Sometimes, the rest are more ISV scenarios. So sometimes as an ISV, you may want to split up the packages depending on how often you expect them to be serviced. So for example, the platform we expect to be serviced quite often, so they want to have that as a separate package with no overlayering so that they can service it fast and frequently. And those things should be lower risk, right, to the business. Those should be less business process oriented and more just like the base of the solution. Then you might have some more medium frequency, things like reporting, where yes, there's risk there, but there's less risk to the business. If a report breaks during an upgrade, there's less risk that I'm going to not be able to run my business. And then, of course, business processes would be a slower update scenario. The next section is whether or not the upgrade is required. This is more for, like an example is if an ISV is doing a country level localization. They may have one package that's like, this is what the lawmaker said your system has to have. And they may have a second package that's, these are optional things that are nice to have for your country. So when people pass new laws, I can give them a new package and a new model file for just the things they have to have without upgrading the whole solution. So that's another reason to split it up. And then this last one, this can apply to customers, ISVs, I believe it applies to Microsoft, where if I'm splitting up my development work between teams, then I can split out the package because it kind of helps with code organization. It makes the compiles faster when I'm compiling that package, and I don't have as many dependencies between people. So, I may want to, maybe I'm doing a customer project and I have a bunch of manufacturing changes and a bunch of finance changes. So maybe I want to split those into 2 packages so I can kind of keep them on their own development cycle. This is an example from our solution, just to, I don't know if these things are right or wrong. I just wanted to give a real world example of something that we've done. So in our solution, we split things up into 4 packages. We have, I'm going to start from the bottom up here. So we have kind of our core solution, that's business process related features that everything gets built on top of. And then on top of that, we have the BI package. Again, this has to do with this frequency of update. So we wanted to be able to service our customers more often in terms of BI. So we split out that code base into its own package. And for us, that also works because it was a separate team developing the BI versus the team building the core features. This next one, we had like one specific feature that was dependent on somebody else's DLL file. So we decided to split that out as well as kind of a just in case thing, just in case something happens with the compatibility of that DLL, we would be able to service our clients and update that component of the solution. And then finally, workspaces, mainly they got split out because workspaces are dependent for us on the BI package and the core features package. So they really needed to be split out because of kind of the development cycle and the dependencies of the workspaces. And that was another one we thought that we might want to upgrade more frequently, the workspaces versus the core features. So again, this is just an example. It's not advice on how to split the packages. It's just an example for one solution of how we split it up in a way that made sense to us. As I mentioned on the slide, this all started as one. We just started by upgrading from AX 2012 and kind of learning along the way. But as we kind of rolled into it and got going, we decided that some of these things should be split out further than just having one giant package. So how does extensions impact design? First of all, I think the key point is that extensions should influence the design. This is true for both functional and technical consultants should be taking into account kind of what AX can do and trying to design things in a way that they know the design will be extendable and the design will use extensions. So just kind of at that conceptual level of a solution, I think it's important to keep these concepts in mind. And for us, what we've told our developers is by default, all of your work should start in its own package. And it's really an exception if you have to do overlayering, and that exception should drive some kind of conversation. It should be a conscious decision that, hey, I can't code this the way you asked for because these reasons, and then have the conversation. Sometimes the answer is you have to do overlayering. Sometimes you have to modify something that's in the middle of a method, in the middle of a class, and the only answer is overlayering. And so that's just the reality of what we live, and we have tools to manage that, but we want that to be a conscious decision. We don't just want it to be kind of inertia that I've always done overlayering, therefore I'm going to keep doing it. Yeah, so I think that this is it's kind of very high level, but it's just a critical point that, because if you don't do it this way and you just do overlayering, then again, you're impacting the long-term ability to upgrade the solution. So we've talked a lot about extending in terms of making extensions to Microsoft's solution, but there's also kind of, if you're in the middle like an ISV, there's some other considerations that you need to make. So if you're in the middle and you want to make your solution extendable so that your customers aren't overlayering your solution, then this is some tips on how to do that. And the tip really is to communicate, because as a product designer, you aren't always able to anticipate at the beginning exactly what kind of customizations people are going to do. Sometimes you just don't dream up their business scenario that they're going to end up coding on top of your solution. So if you develop that relationship, then you can kind of get some feedback that, hey, we wanted to do this kind of customization. And you might say, as a product designer, well, that type of customization makes sense. I'm going to give you some hook points so that you don't have to overlayer my solution, that you can just extend it in the way that you want to. So I don't think it's really possible to just dream up every scenario off the top of your head. It's really getting the feedback from your customer base on what they want to do. And Microsoft has started to do some of those things. If you're there's some Yammer R&D groups, especially around like platform and foundation, where they've started to ask these kind of questions. So they've said, okay, what can't you do in the platform that you want to, and give us the feedback so that we can bake it in and make the platform, make the foundation extendable in the way you want. Thank you. When customers do overlayer, they make it harder to upgrade your solution. So, one of the things you don't want as an ISV is to kind of get stuck where somebody makes a bunch of customizations on your stuff, and then you're stuck supporting things for years and years because the customer can't upgrade it. So, making your solution so it's extensible helps the ongoing servicing of your clients, and helps you so that your code base doesn't have to be as old for your support team. So it's important to make your solution extendable so that it can be upgraded and on an ongoing basis. Finally, let's talk a little bit about code upgrades. So if you've been to other sessions, a lot of times the code upgrade gets described like this. You run it through LCS, and then you get it to compile, and you upload it to LCS, and you're done. Well, I'm going to tell you that that's not the full story. We're missing some key points in this process. Because by default, all of your upgraded code is just going to go into the standard AX packages. There's no package splitting that happens through the upgrade tool. So when you're upgrading from 2012, basically 100% of the code is, they'll create the extensions for you. The upgrade tool will create the extensions, but all the extensions are sitting in the application suite or application platform packages. So they're not splitting them out into your own custom packages. So that whole story is a manual process to go back through and refactor these things and get it split out into your own separate package. And I guess I wouldn't underestimate the time and the effort that that's going to take. It's not necessarily an easy process, because a lot of times when you're going through this refactoring process, you have to do things like write new delegates in your code. You may, you guys didn't talk about delegates, did you? So delegates are just a way of putting like one piece of code in the application suite that can talk to your package that's in a separate package. So it's just a way of of packages communicating with each other when they're not dependent on each other. So there's ways that you can do kind of, I guess I would call it a minimum level of overlayering, but have most of it in your own package in extensions. So that process to go through is just, it's really important to go through, because if you don't go through it, you're going to impact your long-term ability to upgrade your AX7 environment after you upgrade from AX 2012. I will give a little bit of advice on how to go through this refactoring process. So like I said, everything comes into the application suite in kind of one, or it just comes into the application suite packages or the standard Microsoft packages when you go through the upgrade process. So in general, when you do upgrade, you want to first kind of refactor your code inside the application suite. So you're basically making sure everything's extensions that could be extension based, or if you have to do overlayering, making sure that it's done in the right way. And of course, make all that compile. Then you have to, all of the extended objects you have to remove, and today that's just through the file browser. You have to manually take the objects out. And at that point, you should be able to compile again. I say compile and fix issues because it's tough to get this perfect the first time. So you cut all the objects out and you compile, and that also lets the compiler know that those objects are gone. So that's one of the reasons you have to compile at this point, so it knows it's no longer in the application suite. Then once you get the application suite to compile, you paste all of these objects back into your package directory. And at that point, you should be able to compile again. Now the compiler knows the objects are back, but that they're in this other directory. And then, of course, you go through the testing process. So it is quite a few steps. Obviously, there's quite a few compiles in here, and these are full compiles. So even just the compile time of doing this is part of the reason it takes so long. I think when we did it, I gave my developer 2 VMs and said, okay, work on 2 features, but kind of switch back and forth so you don't have to sit there and wait for it to compile the whole time. And that's what I would, one of the tips I would give is, if you have a larger solution, maybe even for smaller solutions, I would suggest doing 1 feature at a time when you do this refactoring. So just don't try to take the entire code base and split it out into its own package. We tried it and we got 1,200 compile errors when we tried to split all the extended objects out. So there's just lots of little things to fix as part of this, so it's easier to narrow the focus down, and we found doing it feature by feature was much more successful.
So let's take the opportunity now to go through some questions. I'm sure you will want to take the opportunity where we have a distinguished member here in the industry, that you can ask all questions about your scenarios. So, I think we have microphones down there. If you could step up to those, or just raise your hand and we'll try to paraphrase the questions. But let's get some questions here. Maybe it's just because it's dark in here and I can't see the forest of hands going up.
I have a question about USPS and build processes. So do you guys use this, like automatic builds with Visual Studio Online?
Paraphrase the question.
Yeah, the question was about automatic builds, and I'll actually let you talk about that a little bit.
I think I will leave it to Robert then.
Well, I'm just going to keep passing it.
So I think, Joel, you guys were in the process of adopting this soon, so that
Yes.
you haven't used it yet.
Yeah.
But did you want to know about the process, or you just want to know if Joel is using it?
No, just different tweaks, because I also know the process, but we are also in the process of adapting that.
Mhm.
And it's not so easy. It's like, theoretically, it's simple. In practice, let's say branch management. I know that Microsoft inside, they don't use like, branch management properly. They trust developers more. I was thinking about, maybe we have some, tips about using branches and also like doing code out of services, something.
Yeah, it's a little beyond the scope of how much time we have, especially when you go into branching. But we have had several ISVs. Are you from an ISV organization?
We are an ISV.
Okay. We have several ISVs who have been using build automation and even customers now who are in their live implementation. They actually, when they deploy their tier 1 environment, they're opting for deploying a build instead of a dev because they're developing on premise. So it is a feature that has been uptaken by several ISVs and customers. It only gets complex. That's why maybe I can hear from you after that session. It only gets complex when you want to customize the build process. But if you're simply doing what Joel was saying, is building code, checking into version control, and you're always building your entire solution or all the code in that particular branch, developers don't even need to know it exists. It's actually scheduled automatically. So I would like to hear more about what you think is complex in it, and maybe we can do that after the session.
I'm just trying to, overprotect probably us.
That's fine.
One question. You talked about, your own ISV package and teaching customers to, use extensions to get over there. Is it possible to lock down your own packages? Or
No, we haven't made the facility where you can do what we have done, which is to lock down the thing so that you can, well, you know how that works. We have not made that available yet. I trust we will at one point, because it's a benefit that I would expect many partners to want to have, to be able to service their customers the same way that we do, where they can at any time, after fair warning, of course, roll in updates to their stuff and have others that build on it not be impacted by it. It's such a strong value proposition that I would expect us to go down that road and actually build that and ship it and document it along the way. Yeah, go ahead.
Yeah.
There is a way to do it that is only a functional way to do it. I think Peter was referring. So there's a property in the model descriptor that was shipped with update 2 of the platform, where you can set your model to not allow customizations. So you're almost contractually locking it. Your customer can still go and basically say, I don't care, I'm going to change it. But this would not be recommended. So the answer is yes, there is a way to do it, but it's not purely locked. If somebody wants to cheat, they're still going to do it. It's almost like changing a private API into a public API if a customer does it, which would not be recommended.
But there are also tools that make sure that there is binary compatibility, so that you don't, from one version to the next, say, add a parameter to a function, which would mean that the guys that were using you could no longer load the assembly and you would be broken. We have some tools that validate that that doesn't happen from one build to the next. Those are the kind of tools that we have not published yet, which you would need in order to make sure that you didn't break your customers when you did this. So there is more than just setting the property in the descriptor file, which you can certainly do. We've documented in a blog how to do that, but we don't give you yet the complement of tools that you need to actually drive it. But we will.
So your question was about refactoring what part of
multiple packages.
Yes.
For example, doing your reports or UI in one package.
Right. So why didn't I say to do that for the customer packages? I think the scenario that makes the most sense is for split dev teams. That would be a good reason to split them out. The reason it's not quite as applicable for customer packages is because you don't have upgrade scenarios. Like you're not bringing a customer package from somewhere else to upgrade. You're just, as part of the upgrade process, you're fixing any issues that come up. So in general, you kind of the customer package always has to kind of get upgraded every time you install new underlying models or new underlying packages. So
You could have more expensive customer modifications that also would kind of like fall into the, a basic part and, some things over the basic part. So it could make sense.
right. Yeah, so the question was, for a larger customer solution, could it be big enough that it makes sense to split it up? The answer is yes. All I was saying in my presentation is, for us, the default answer is one customer package. If you get into a larger solution or you get into scenarios that make sense, yes, absolutely, you can split that into multiple packages, and that could totally make sense.
The other question I have, so it seems to make sense for both price and customer, but it seems like we're paid to do time consuming. So does Microsoft have any intention to kind of create tools for us to help with that?
With the refactoring. So the question was, and I'll ask Peter and Robert the question. The question was, the refactoring is time consuming. What do you guys think from a tooling perspective? How do we help the community to make it more efficient?
Well, one of the things that we have done is that I'll discuss this on my session on Friday, is that we have opened up the tools that we use so that people can tie into the code story in any way they want. It's not perfect, but you can actually write refactoring scripts and understand your code at a level where you have never been able to do before. We have opened up the stuff exactly like the Roslyn guys have done for the C# and managed space. We have for X++ as well. You can easily write scripts that understands your code and does things to it. This was not possible before, but it's possible today. And that's the only thing that I can say. We don't have a general refactoring framework, which I would really love, and we would tie it into Visual Studio, and you would do great things from there. But we don't have that yet. Let's hope we will get the investment to do that.
One example that we didn't ship yet, but it's in our backlog of feature is the stuff that Joel spoke about, where you use File Explorer to cut and paste files. We were working on designing a refactoring tool that converts overlaying to extension. Currently, you don't actually have to go to File Explorer. We support it within the project system, but it's still a cut and paste. But we do want to get to a place where there's more smarts behind this. So when you move something and there's some sort of wizard experience, you're refactoring something from overlaying to extensions. It understands more the code you depend on. It will suggest you move this code with it, and so on. It's quite a complex topic, but it's something we will be looking at some point.
And for our experience has been that the refactoring is also kind of ongoing. I mean, it's been ongoing through 2016, because every time we refactor, then update 2 comes out and there's new ways to do extensions. And now we have to go back and say, okay, well, what did we do before as overlaying that now we need to do an extension? So it is kind of a continual improvement thing over time.
Correct. And just to in the first versions of the code upgrade tool, for folks who were in the technical preview program, I don't know if you remember that, the code upgrade tool tried to be smarter than it is today. And it failed. So that's why we went back and said, we're not going to create packages for you. Basically, our first attempt was to actually not only create extensions for you, but also move the code into different packages and so on, and try to convert some methods into event handler and stuff. But then we realized there is nothing a computer can do at this stage. And we basically made it a little simpler again. We did whatever we can with metadata. We kept it at least in a way that it can compile and build. So at least we give you the choice of, releasing something and refactoring later, which is Joel is recommending against. But that's fine. But at least we gave you the choice of something that runs within a week of work, or a couple of weeks that compiles and runs. And then you can slowly refactor, but not on a broken application.
Yeah, I would say, I mean, if you're a customer, maybe you can refactor over time. If you're an ISV, I feel like it's a terrible idea, because once you get code into production, now you've already hurt the servicing story. And when you go to service that code to put in the refactored code, it's going to be a struggle.
Correct, but at least a running application, even if you don't go live, you can
Yeah.
test it internally, right?
Yes.
You do have a running application across your entire organization.
Yes.
So that's why we kind of kept the upgrade simpler, where it stays within the package. And then you can, over several months or a couple of months, you can actually refactor. But in the meantime, your application is running, so your own developers can test it, can debug
Yes,
it, and so on.
that was our strategy or one strategy is to just, comment out all the compile errors and then start hitting one feature at a time, refactor and take care of any of the compile errors that you compiled out. So if I was doing it all over again, that's exactly the process I would go through, is first get a compiled application and then do this over time.
Yeah, never underestimate the value of having a running system, even though it's not complete. But having a running system so that you can see the heartbeat of the thing is important on so many levels. Psychological is one level, but there are technical levels as well. So with this, I'm afraid we have to stop today because we're probably going to get thrown out soon. Please remember to sync up with us. The three of us up here will be happy to answer questions. If you catch us around there with a lunchbox or something, we're always happy to help where we can. You do your part and fill out the evaluation for the session so that we can improve and do this better another time. So with that, I would like to thank our guest speaker who did a remarkable job. Thank you, Joel.
Thank you.
Thank you very much.